Hello there again. This is Algebra 1, Chapter 3, Section 6, and it is the last section in the chapter. You know what that means. Dun, dun, dun. Examino for you. Before we get there, we want to kind of leap off or piggyback, I guess, off of the previous lesson, which was 3.5, which talked about direct variations. And today's lesson is about proportional and non-proportional relationships. And so I have two bullets here just kind of describing what those things are. In a proportional relationship, the graph will always pass through 0, 0. And that should sound really familiar because we know that in the previous section we were dealing with direct variations. And we also stated in that lesson that the graphs always pass through 0, 0. So that tells us that direct variations are a type of proportional relationship. And so a lot of what we're doing today is going to kind of seem really familiar to you. But the one that you want to focus more on is the non-proportional relationships. But we're going to start with proportional. And like I said, a lot of this will be really familiar because it's going to look a lot like the previous section. But let us get started here. It says, Marcos is so cool. Marcos is a personal trainer at a gym. In addition to his salary, he receives a bonus for each client he sees. Now, I think to myself, what if I got a bonus for every student I saw? Wouldn't that be awesome? But no, it doesn't happen. So anyway, carrying on will be sad. So here we go. Well, first thing it asks us to do is just graph the data. So I have a big old graph over here already kind of pre-made. And we want to put number of clients over on the x-axis, and on the y-axis the pay. So for 1, you want 45. I'm going by 20s. So here's 1, 20, 40. Maybe right about there is 45, a little bit above the 40 mark. 2 and 90, so here's 2, and there's 80, and there's 90 in the middle. And then 3 is 135, so we're going to go all the way up here, almost close to the 140. 4 is 180, so 180 is right about there. And then 5, 225 is going to be over here. A little bit after the 200. So that's pretty much my graph. It looks very linear. It might be a little off because my graph is not perfection here, but it does ask us a question. It says graph the data, which we just did. What can you deduce from the pattern about the relationship between the number of clients and the bonus pay? I can tell you right now, just by looking at the graph, that it basically looks like a linear relationship. But also, I think that the graph will pass through 0, 0 because that would make sense. Because, again, if I had 0 clients, which would be like x 0, then my bonus pay would be 0 because I wouldn't be making anything off those clients. So that means that I'm also going to be passing through 0, 0. So when you have a linear relationship that's passing through 0, 0, pretty much that means for you, let me put this point a little bit more where it should be. Was it 3 and 135? I think you want to be right about there. All right. So we can basically say that this is going to be a proportional relationship here as my answer. I can't even spell. Let's see here. Proportional. Where's that word? Prop 182. Okay, so we got, let me see, I want to try to spell this correctly. Yeah, see, I was doing it right. Proportion. Oh, there we go. It is a proportional relationship because it passes through 0, 0 and it's linear. Now in part B, you want us to write an equation to describe the relationship, and we've done that in the previous lessons. What we need to do is find our k value, right? It's going to be y equals kx to some extent. So we want to be able to find our k value. So the way that we do that is basically you can do it by finding the difference or looking for a pattern in the equation. So what I'm looking for here is, and I don't know how I'm going to write that up there without you being able to see, but here we go. Between 1 and 2, there's a plus 1 value. 2 plus 1 is 3. 3 plus 1 is 4. And 4 plus 5 is 4 plus 1 is also 5. So basically on the x-axis, we're adding 1 every single time. And then for the y's, if I add 45 to 45, I get 90. And if I add 45 to 90, I get 135, and if I add 45 to 135, I get 180, and of course if I add 45 to 180, I get 225. So on the y-axis, I am basically adding 45 every single time. So the difference between the values for the clients is 1, and the difference in the values for the pay is 45. That means my k value is basically like my slope, which is the change in y over the change in x. So the change in y, which is the bottom here, is 45, and the change in x is 1. So basically, my k value is 45. So my equation will be y equals 45x. Alrighty, that's part B. And then in part C, it says use this equation to predict the amount of Marcos's bonus if he sees 8 clients. So that just means I want to find the y value when x is 8. So I'm going to come down here and say y equals 45 times 8. And 45 times 8 is apparently $360. So he'll have a bonus of $360. I told you he was cool because he gets bonuses, see? So that's how you do this, little guy. So now I'm going to let you try this one on your own. Remember, you have to graph the data first, write the equation, and then predict with your equation. And then we're going to go to something that's more of a not proportional or non-proportional relationship and kind of go through that. So it says here, write an equation in function notation for the graph. So I've kind of already got things started for you here. The graph was given over here on the right. And so what I've done is, and you should do as well, if you look at the graph, there are about 4 points on the graph that are kind of already highlighted for you. So what I want to do first is put those values in a t-table like we had in the previous example. So when x is 1, it appears that we're going by 3's here on the y-axis. So x is 1, 3, 6, 9. So when x is 1, y is 9. When x is 2, we're going to get 12. When x is 3, we're going to get 15. And when x is 4, we're going to get 18. Alrighty then. And I probably should have mentioned this earlier, and I'll say it now. One of the reasons why we know that the previous example is proportional is because if I take the ratio of x to y every single time, I'm going to get the same value. Where is my... Wow. In other words, if I go 1 over 45, I get 1 over 45. But if I go 2 over 90, that fraction is going to reduce to 1 over 45. 3 divided by 135 is 1 over 45. 4 divided by 180 is 1 over 45. And 5 divided by 225 is also 1 over 45. They're always the same. But in this example, and that was the proportional example, but in our example now, we're going to do that. We're going to compare 1/9 to 2/12. And we know that 2 goes into 2 and 12 evenly. So we're saying, does 1/9 equal 1/6? Because 2 goes into 2 once and 2 goes into 12 6 times. But again, you see, you don't get the same ratio. And the same is true for 3/15. Does it equal 3/15? In the case of 3/15, that's going to reduce to 1/5. And then 4/18 is going to reduce, these are the questions here, 4/15 is going to reduce to 2/9. 2 goes into 4 2 times, and 2 goes into 18 9 times. So the question here remains, now that I've reduced all these fractions, none of them are the same. 1/9 does not equal 1/6, does not equal 1/5, does not equal 2. None of them are equal to each other. So that's how we know that it's not proportional like it was earlier. Also, the other thing we can tell is that this graph is not passing through 0, 0, which is what it's supposed to do. So that's how we know that it's not going to be proportional. So now we know that it's non-proportional. but then it's still asking us to write an equation in function notation. So there are some things that we can do to kind of help us write a function. So let me erase some of this stuff that we don't need anymore. We're going to go back here. I need some space, so I'm going to get rid of this stuff here. And like the previous example, we can find the difference in the x values. Add 1, add 1, add 1 each time. So it looks like it's the same as before. Here we're going to add 3, add 3, add 3 each time. So that kind of tells us a little bit about our k value. Changing y, we're changing x. So we are going to know that our function is going to have some sort of y equals 3x. Now if they want function notation, technically we should be saying f of x equals 3x, but they're the same thing. But if we try this formula, when I choose an x value, like if I choose x, like if you're thinking to yourself right now, this is the function, then you can test it by plugging in the numbers to see if they work. If I plug in a 1 in the x's place, then 3 times 1 is 3, but it's supposed to be 9, and it's not. So we need to figure out how do we get a 9 from this equation. So one thing I can do is that basically if I plug in a 1, I'm going to get 3, but the answer is supposed to be 9, and that's 6 larger than 3. So I'm going to go ahead and add a 6 to it and see if that works. Okay, so again, I try the 1 again. So this time if I go 3 times 1, I'll get 3, and then 3 plus 6 is 9. So it worked for that ordered pair. It needs to work for all of them. So now I'm going to try the 2. 3 times 2 is 6, and then 6 plus 6 is 12, so it worked again. 3 times 3 is 9, 9 plus 6 is 15, worked again, and then 3 times 4 is 12, 12 plus 6 is 18. So now it worked for all the points, so now we can pretty much safely say that our function is going to be 3x plus 6, or f of x equals 3x plus 6. So I hope that that made sense. And now you are going to try a very similar thing at this do-it-yourself question. And this time, you're going to have 2 different examples. It says to do the same thing we did in the previous example, but this time you have information that's in a table, and then you have one that's in a graph. So remember, for the graph one, the easiest thing to do is to take those 1, 2, 3, 4 values, and maybe make a table out of it so you can make that a little bit easier for yourself. So once you've completed this do-it-yourself example, then you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.